Good morning to all. I am Dr.Dhondiba, Assistant Professor of Chemistry, Government First Grade College, Kerala, Bangalore. Today I am going to discuss about the 20th session of Chemistry and third session of Surface Chemistry, which belongs to third semester BSc affiliated to Bangalore North University. In this session, I am going to discuss about catalysis. Now, aim of these sessions are objectives of these sessions are meaning of adsorption catalyst, then examples, characters of adsorption catalyst, then types of adsorption catalysis, then theories of adsorption catalysis. These we have to discuss one by one in this session. Now, after this completion of this session, you will know about what are the adsorption catalysis, homogeneous and heterogeneous catalysis, then theories of adsorption catalysis. You will come to know after this completion of session. Then before discuss of this session, you already know about meaning of catalysis and the general applications of catalysis. Also the general types of the catalysis you have already known. Now coming to that is the catalysis. What is mean by catalysis? A catalyst is a substance that alters the rate of a chemical reaction without being itself used up in the reaction called that is a catalysis. Or also say that a substance which alters the rate of the reaction without being itself used up in the end of the reaction, and that is called as a catalysis. An example is called that is a potassium perchlorate KClO3 undergo that is a manganese dioxide to form that is a 2 molecules of the KCl and 3 molecules of the oxygen. Again that is in the preparation of sulfur trioxide. Sulfur dioxide undergo a oxygenation, that is passing the oxygen gas to the sulfur dioxide gas in presence of that is a vanadium pentoxide to form that is a sulfur trioxide. This is the vanadium pentoxide. This is act as a catalyst, and here in manganese dioxide is also act as a catalyst for this reaction. Now coming to the what is the general characteristics of catalysts. First one is the catalysis or catalyst remains unchanged in the mass and chemical composition at the end of the reaction, because the catalyst cannot be participate in the end of the product. They remains unchanged in mass and chemical composition at the end of the reaction. Then second character of this catalyst is small amount of catalyst is needed to bring out the desired change in the chemical reaction. It is just small quantity is required to get the alter the rate of the reaction. Third character of this catalyst is a catalyst cannot initiate or start a chemical reaction. It cannot be initiate or start the chemical reaction, but it alter the rate of the reaction. Fourth one is it is a specific in its action. It having a specific action, means it whether it is a speed or it make the speed of the reaction, or it is a decrease the rate of the reaction. That will be a specific action will be takes place by using a catalyst. Fifth character of catalyst is the catalyst cannot alter the nature of product of the reaction, because what it is the nature that remains as it is. Suppose it's gaseous state, that will be remains in gaseous state, or that is whatever may be, it cannot be alter the that is the nature of the products. Then sixth one, catalyst does not alter the position of equilibrium in the reversible reaction, because here just simply it is a speed of the rate of the reaction or change the rate of the reaction will be takes place, but it cannot be alter or it cannot be changes the equilibrium position of the reversible reaction. And seventh character of catalyst is nothing but a catalyst gets poisoned by certain substances called poisons, or improves the activity of the catalyst called that is the promoters. Therefore, the catalysts are two types here. One is catalytic poison, means it slow down the rate of the reaction, slow the rate of the reaction, activity will be a decreases, and that is called as a poison. And the catalyst activity is increase or improve the activity called that is promoters. These are the few characters of that is catalysis. Now come to that is the phenomena of changing the rate of the chemical reaction by the use of catalyst is known as catalysis. What is mean by catalysis? Catalyst is the substance, but catalysis is the process, because a phenomena or a process of the changing the rate of chemical reaction by use of catalyst is called that is a catalysis. There are two types of the catalysis. One is called as a homogeneous catalysis, another one is called as a heterogeneous catalysis. If the catalyst and the reactant are in the same phase, means whether it is both are in liquid state or in the solid state or in gaseous state, therefore the catalyst and reactant should be same phase, then they are called as a homogeneous catalyst, and the phenomena is called as a homogeneous catalysis. Example for this, the conversion of that is a sulfur dioxide into sulfur trioxide, passing the oxygen gas to the sulfur dioxide gas in presence of nitric oxide as a gas, here gas, and to form that is a sulfur trioxide. Here the sulfur dioxide is gas, again oxygen will be a gas, these are both are reactants, and catalyst that is a nitric oxide, it is also in the gaseous state, therefore it is called as a homogeneous catalyst. So again that is another one, the conversion of carbon dioxide, that is carbon monoxide into carbon dioxide, passing the oxygen gas, here both are that is reactants and nitric oxide, these are all are gaseous state, hence it is called as a homogeneous catalyst. Another I will take that is example, ethyl acetate. Ethyl acetate is in liquid state, and water also is called as a liquid state, and HCl as act as a catalyst, therefore hydrochloric acid is act as a homogeneous catalyst in this reaction. Therefore here HCl is the liquid state, and ethyl acetate and waters are also, these are the reactant, they are in liquid state, and to form that is acetic acid and ethanol. Therefore these are called as these example for that is homogeneous catalysis. Now coming to the heterogeneous catalysis. In the heterogeneous catalysis, the reactants and catalysis are different phases. The reactants and catalysts are in different phases, called that is a heterogeneous catalyst. Are those reactions in which the reactants and catalysts are in different phases, called that is a heterogeneous catalysis. Now for example here, ethylene is this is actually it is a ethylene, it is gaseous gas, and oxygen, hydrogen is also gas, passing the hydrogen gas to the ethylene gas in presence of that is a platinum as a solid, that is solid platinum. Here these reactants are gaseous state, but platinum is act as a catalyst, and it is in solid state, hence the formation of the product, whatever may be, that is a ethane gas will be formed. This process or this reaction is called as a heterogeneous catalysis, heterogeneous catalytic reaction, heterogeneous catalytic reaction, because in which the reactant ethylene and that is hydrogen gas, and also that is a catalyst platinum as in different phases. These are the gaseous state, and it is a solid state, hence it is called as a heterogeneous catalysis. Another example is nothing but nitrogen gas and oxygen gas, that is hydrogen gas, they mix with each other in presence of the iron. Iron is a solid, and molybdenum, that is act as a promoter usually, iron is act as a catalyst. These are both are solid state, and these are the liquid state, and form that is the ammonia. Therefore these are the heterogeneous catalytic reaction, and this catalyst is called as a heterogeneous catalyst. And the third one is that is a conversion of the sulfur dioxide into sulfur trioxide, the vanadium pentoxide. Vanadium pentoxide is in solid state, and sulfur dioxide and oxygens are, these are the reactant in gaseous state, hence it is a heterogeneous catalysis. Then coming to that is a theories of catalysis. There are two theories put forward to explain the mechanism of catalysis. First one is intermediate compound formation theory. Second one is adsorption theory. Now intermediate compound formation theory that can be explained here. This theory is generally applicable to homogeneous catalysts. This theory, intermediate compound formation theory, generally applicable for homogeneous catalyst. The catalyst combines with one of the reactants and forms unstable intermediate, which later combines with other reactant to form the desired products, and to get that is degenerate the catalyst. Therefore, here first one is the catalyst combined with one of the reactant and to form that is an intermediate product. Then again that intermediate product combined with that is another reactant and to generate that is a catalyst free. Therefore, this type of that is a process is called as the intermediate compound formation theory. Here, for example, in this reaction, the type A plus B to formation of AB. Now this is the reaction. These are the A and B are the reactant, and AB is nothing but formation of product. In presence of the catalyst C, suppose it is taken as considered as a catalyst. Then the reaction mechanism may be written as first catalyst combined with one of the reactant, that is here say that is A reactant combined with C to form that is AC. This is the unstable intermediate. Then this AC combined with other reactant, that is B, and to form that is AB product, and C will be a set free. It is degenerated. It is combined and to form that is unstable product, and this unstable product combined with other reactant and to form that is product with liberation of catalyst, and it is set free in the product. The activation of energies of the above catalyzed reactions are lower than the activation energy of uncatalyzed reaction. Hence, the reaction proceeds at the faster rate. Because without this reaction A plus B to formation of the product, but it is a slow reaction. But when the catalyst is used, this rate of the reaction will be fast. It is increases. Another example quote here: the oxidation of sulfur dioxide to sulfur trioxide. The oxidation of sulfur dioxide to sulfur trioxide in presence of nitric oxide gas as a catalyst. Another example for this, the sulfur dioxide react with oxygen in presence of nitric oxide to form that is sulfur trioxide. Mechanism of this reaction can be written as how it is: two molecules of the nitric acid, this is the catalyst, and one of the oxygen is nothing but oxygen in the form of gas to form that is a nitrogen dioxide. Nitrogen dioxide, it is an intermediate product, it is unstable. Then this unstable product will be combined with that is other reactant, that is sulfur dioxide, and to form that is a product with the liberation of that is nitric oxide as a catalyst set free. And this theory is called that is intermediate compound formation theory. Now come to that is adsorption theory. Adsorption theory, adsorption theory is particularly for that is heterogeneous catalysis. The heterogeneous catalysis is best explained by this theory using adsorption theory. Generally, the catalyst is a solid and the reactants are usually gases or liquids. In the adsorption, usually you see the solid as adsorbate, and that is gases and liquids are adsorbate. That is adsorbate, and these are called as adsorbent. Okay. Now here, according to this theory, the reactants gets adsorbed on the surface of the solid in particular orientation. The reaction takes place between the adsorbed reactants and products are formed due to the decrease in energy of activation for the reaction. Once the product are formed, they are desorbed from the catalyst. They are desorbed from the catalyst. The non-uniformity on the surface of the catalyst is the main criteria for the reactant molecules getting adsorbed on the surface. This is the how this is takes place. Now the imperfection. The imperfection on the surface of the solid catalyst, that is edges, cracks, corners or peaks having an unsatisfied valence is called that is the active centers or active sites of the catalyst. Now here usually you know that the non-uniformity on the surface of the catalyst is the main criteria for the reactant molecules getting adsorbed on the surface. Therefore, surface should be not a uniform, it should be a making that is a non-uniformity. If the surface of the solid is uniform, then adsorption is not takes place properly. That should be a make it is a non-uniform by taking that is a cracking or corners or edges or peaks, whatever may be, the producing, the making the imperfections on the surface of the solid, that is edges or cracks or corners or peaks having unsatisfied valences, or that is the active centers or active sites of the catalyst. They may ask questions in the examination, what is mean by active centers? Means the catalyst edges or cracks or corners or peaks having unsatisfied valences on the surface of the catalyst, or that is active centers. And that active centers, they have the ability to absorb the gas molecules or liquid molecules on its surface, and adsorption is takes place. Increase the number of active centers increases the activity of the catalyst. By converting the solid into finely divided state, by powdering the surface area of the catalyst increases due to the increasing number of active centers. Therefore, finely powder catalyst, they are it is used for that is making the fast of the reaction. The activity will be increased because the active centers will be increases. There are some substances which may not be catalysts, but increase the activity of the catalysts by increasing in the number of active centers. Such substances are called that is promoters, catalytic promoters. What is mean by catalytic promoter? There are some substances which may not be catalyst, increases the activity of catalyst by increase in the number of active centers. It may be increase the active centers on the catalyst, and such substances are called that is a catalytic promoter. Example, the effect of molybdenum on the surface of the iron in the manufacture of ammonia by Haber's process. Here molybdenum is act as a promoter. The substances which retards the activity of the catalyst is called that is a catalytic poisons. Means a substance, the activity will be decreases, that substance is called that is a catalytic poisons. These substances decrease the number of active centers. That is promoters are nothing but it accelerate the or increase the active centers on the catalyst, whereas the catalytic poisons are it decreases the active centers on the surface of the catalyst. For example, the action of carbon monoxide on the iron in manufacture of that is ammonia by Haber process. The carbon monoxide is act as a catalytic poison, and the rate of the reaction will be decreases because of that is the activity of that catalyst will be decreases, or active centers will be decreases on the catalyst. And these are the example for that is the catalytic promoters and catalytic poisons. Now so far we have discussed about that is the meaning of catalyst, then example for catalysis, then characters of catalysis, then theories of catalysis, intermediate compound theory, and that is the adsorption theory. Then we have already discussed these one by one so far. Therefore, you have already understood this session very well. Therefore, I will ask some questions. Please, you have to give right answer. The first question goes to: a substance that alters the rate of chemical reaction without being itself used up in the reaction is called. There are four options are there. A option adsorption, B option adsorbate, C option adsorbent, and D option is catalyst. I will give just 10 seconds for you people. You have to select the correct answer. The D answer is, the D option is the correct option of this question, because a substance that alter the rate of chemical reaction without being itself used up in a reaction is called as a catalyst. Therefore, D option is the right answer for this question. Then question number 2, how many types of the catalysts? The A option, the 3, B option 2, C option 4, D option 5. I will give just 10 seconds for you people. You have to select correct answer for this question. The B option is the right option, because there are two types of the catalysis are there. That is the B option, that is the 2. The how many types of the catalyst means there are 2 types, hence that is the B option is the right option. Then third one, the imperfection on the surface of the solid catalyst is called, the imperfections on the surface of the solid catalyst is called, 1, A option active site, B inactive site, C promoter, D poison. I will give just 10 seconds for you people. You have to choose the right option. The A option is the right option for this, because the imperfection on the surface of the solid catalyst is called active sites. Active sites. Hence, the B option, that is sorry, A option, that is active site, is the correct answer for this question. Then fourth one, intermediate compound formation theory applicable for A, homogeneous catalyst, B, heterogeneous catalyst, then C, both option A and B, and D option, none of these. I give just 10 seconds for you people. You have to choose the correct answer. The A option is the right option, that is homogeneous catalyst. The intermediate compound formation theory is applicable for only homogeneous catalyst. Then fifth one, adsorption theory applicable for, that is A option homogeneous catalyst, B option heterogeneous catalyst, C option both A and B, and D option none of these. Just I will give just 10 seconds for you people. You have to select right option. The B option is the right option for this question, because the adsorption theory applicable for only heterogeneous catalyst. And this complete this session. For making this or for preparation of this session, I made these reference books for preparation, and thank you.